we're going to move on to our next speaker, Amina Jambo, who is going to talk to us about a lunar architecture module. Amina, can you hear me?
Yes. Oops, sorry.
Okay.
Can you hear me as well?
Yes, I can.
Great.
Go ahead.
Okay. Hi, everyone. I'm very excited to be joining you today. I'm a habitability scientist and designer for human wellness in extreme environments. And I'm here to present some key factors to be considered as we seek to develop a robust lunar architecture module, or the vessel that will house our tools, experiments, and astronauts during our extended stay on the surface of Earth's moon. Next slide, please. So we know that on Earth, mineral dust comprises more than 50% of the global load of aerosol mass. So we do have an understanding of how dust affects our life and related activities. And the largest cause of mineral dust entrainment is human disturbance in or around areas with high susceptibility to dust emissions. So next slide, things like transportation, excavation, and things of that nature. Next slide, please. On the moon, the way that we approach the design of the systems and structures that house our lunar operations can play a major role in reducing dust accumulation and related damage. So the design of our lunar habitats poses the potential to be either the point of greatest vulnerability or one of the greatest opportunities for sustainable mitigation system. From Apollo 16, we learned that acute and long-term exposure to this dust can have a range of long-term health effects, from asthma to bronchitis to silicosis. Next slide, please. And on our lunar landing missions, there was one thing that remained a constant. We saw that crew members could not avoid tracking lunar material inside the moonlanders. So after doffing their helmets and gloves, astronauts could feel the abrasive nature of the dust, as well as smell and even taste the moon. So they described it as something akin to spent gunpowder and perhaps their most memorable experience of the mission. And this is a picture of Jack Schmidt from Apollo 17, who had a pretty significant reaction to the lunar dust, which caused the cartilage in his nasal chambers to swell. Next slide, please. Depending on the structure that we decide upon for the lunar habitat, we might be engaging in activities that have the potential to exacerbate the lofting of lunar dust. So for example, large groupings of inflatables are going to have really different needs and requirements, from compressive structure.
Amina, you have 1 minute remaining.
Thanks. From in situ materials that will require infrastructure and equipment derived from Earth. Next slide, please. Ultimately, the structure we decide on is going to affect the means by which we mitigate dust exposure into the interior of the HAB post-EVA. So whatever strategies we use, whether it's electrostatics or coatings, it's of vital importance that we work collaboratively to ensure that these technologies can be integrated into or work in tandem with the module's design early on. And I'm working on a set of design strategies for lunar modules to reduce disabling factors and hope to integrate electrostatic removal techniques with my strategies to better ensure the protection of our astronauts and equipment from the adverse effects of lunar dust. Next slide. Please feel free to contact me at my email address listed if you have any further questions or ideas. Thanks you for your time, and I hope to hear from you soon.
Okay.